Automotive air conditioning has been in use for over 60 years, providing drivers with comfort and convenience that adds to their pleasurable driving experiences. Today, it is one of the most popular options for a new car purchase. Air conditioning may be defined as the process by which air is cooled, heated, filtered or cleaned, dehumidified or humidified, or circulated or recirculated. To achieve all of these functions, automotive air conditioning systems rely on the principles of heat, temperature, and pressure to operate efficiently. Heat is one of the basic forms of energy that is present in all matter. In automotive applications, heat is discussed in two forms: sensible heat and latent heat. Sensible heat is any heat that we can feel and that can be measured with a thermometer. For example, we know that boiling water has heat. We can sense it by seeing the water boiling. We could, although we wouldn't, tell that there is heat by feeling the water, and we can measure the heat with a thermometer. Latent heat can be described as heat that is unseen or hidden. Latent heat is the additional heat required to change a liquid to a gas. We know that water boils at sea level at 212 degrees Fahrenheit. We can measure that as we did before, and we know that when water boils, the liquid is changed to gas in the form of water vapor or steam. If we were to measure the temperature of the steam, it would be the same temperature as the boiling water, or 212 degrees Fahrenheit. The unseen or latent heat is the additional heat that excites the water molecules at the surface to move faster than those in the liquid and escape as steam. So in terms of automotive air conditioning, sensible heat refers to temperature, while latent heat refers to a change in the state of matter from a liquid to a gas. Temperature is the measurement of the heat energy that is absorbed and retained by matter. Everything in nature has a specific heat value. Some things feel hot, while others feel cold because of their nature. But regardless of whether hot or cold, everything has some degree of heat. Temperature is an indication of the change in the amount of energy retained, absorbed, or given off by anything. Temperature is measured on either the Celsius or Fahrenheit scales. Heat is measured in calories. A calorie is the amount of heat required to raise 1 kilogram of water 1 degree Celsius. Some form of energy is required to generate the heat that causes the change in temperature. Energy in the form of heat is transferred from one object to another to cause the change in temperatures. So then temperature is the measurement of the amount of heat energy stored, released, and absorbed during the transfer. Heat can be transferred from one object to another through three natural processes: convection, radiation, conduction, and evaporation. Nature always seeks to keep things in balance. Whenever a difference in temperature of pressure exists, the natural laws will tend to move towards equilibrium to the extent possible. Heat will always move from a warmer object to a cooler one. An area of high pressure will always move towards an area of lower pressure. Convection is the movement of heat. There are two components of convection. The first is that heat moves from one thing to another that contains less heat. The second attribute of convection is that as air moves, heat rises. Radiation is separate from convection. It is the movement of heat by heat rays. Radiation does not require air to transfer heat. The best example of radiation is the movement of heat from the sun through the vacuum of space where it is transferred to Earth in the form of solar heat. Evaporation is the process where water is transformed into vapor. As moisture vaporizes from a warm surface, it removes heat and lowers the temperature of the surface. Conduction is the indirect transfer of heat through a conductive material. The car's radiator is an example of conductive heat transfer. The metal of the radiator conducts the heat from the coolant to the air that passes over the radiator. It is a conductive transfer because the coolant, which is hot, never comes in contact with the outside air that absorbs the heat. Humidity is the amount of moisture that is in the air. Relative humidity is the amount of moisture as a percent of the capacity of the air to absorb moisture. Air with a low relative humidity can absorb more moisture than air with a high relative humidity, thus aiding the dissipation of heat. In automotive terms, then, air conditioning systems transfer the radiant heat produced by the sun that is inside the car to the outside air through the processes of convection and evaporation. Pressure is the amount of force exerted by one object upon the surface of another. Gravity acts on the gases in the atmosphere and results in an air pressure of 14.7 pounds per square inch of atmospheric pressure at sea level. Atmospheric pressure is a force that must be overcome in any transfer of energy. Simply, pressure is a resistance to heat transfer. High pressure will generate additional resistance to electron movement than low pressure. Atmospheric pressure at sea level will require a water temperature of 212 degrees Fahrenheit to overcome that pressure and transform the liquid to a gas. If the pressure is lowered, there is less resistance to electron movement. At an elevation of 1 mile, the atmospheric pressure is less, and water will boil at roughly 203 degrees Fahrenheit. Water will boil when it reaches its heat saturation point. That is, when it has absorbed all of the heat possible under the circumstances. The lower the boiling point, the less heat is transferred because the heat saturation point is lower. For automotive applications, the converse also holds true. If a system is put under pressure, the heat saturation point is raised, and the liquid will be at a much higher temperature before turning to steam. Automotive cooling systems use pressure to transfer heat more effectively. Each pound of pressure applied to a cooling system raises the boiling point about 2½ degrees. A system under 16 pounds of pressure will not boil until about 250 degrees Fahrenheit. The heat saturation point of a cooling system under pressure is also significantly raised so that more heat can be transferred from the cooling system to the outside air. Pressure, then, is important to automotive systems in that it increases the resistance to boiling and increases the heat saturation point. And if pressure acts in that way on a liquid, so too does it act on gases. As the latent vaporization point is reached in a boiling liquid, the liquid turns to a gas. As a gas, the volume increases as the molecules spread out. Matter in any form can be heated. Gases can be heated just as a solid or a liquid can. Pressurizing gases increases their heat saturation point. Automotive air conditioning systems use the principles of heat, temperature, and pressure to cause the movement of heat from the passenger compartment to the outside air. The air conditioning system uses these principles to change the pressurized refrigerant in a system from a liquid to a gas and back to liquid, and in the process absorb and release heat. The air conditioner also uses the movement of pressure from an area of high pressure to an area of low pressure to operate. In an automotive air conditioning system, anytime there is a change in pressure, there is a change in temperature. During the pressure-temperature change, there is also a change state from liquid to vapor or from vapor to liquid.